All right, so if your name is JV or Fern, go ahead and here's your bell ringer. Pause it here and try to answer this without checking your notes. We'll see the answer. We just talked about the answer. You guys probably have the answer. Cool. All right. Today, we're continuing on from yesterday. Law of signs and the ambiguous case. Okay, first check. Not the answer that Holloway wants, but the truth. Did what we did yesterday with the wood things help you to, like, very clear, like, did it help formalize and make you see and believe full-heartedly that this happens? Two triangles, they're different. Cool. All right, in this, remember, we are stuck with A and B. I can't change these two. Now, this bottom side, C, could change. I'm going to copy and paste this over and over because we're going to have this picture show up a few times. So yesterday, we were working our way up. We decided that if the altitude or the height of my triangle, when this angle is part of the base, is longer than the other side, I can't make a triangle. I just can't make it work. And then I asked you guys to expand a little tiny bit. And I said, hey, it could be longer, or I remember somebody said it could be shorter, I'm backward. It could be shorter like this, or it could be longer, but there's a middle ground. If A, this side of the triangle, it could be shorter than H, that's what we see here. It could be longer than H, that's what we saw in yours yesterday, but there's a third option. It could be equal. Everybody cool with that? If A is equal to H, and we're going to jump in here and make sure we hit our ambiguous cases. If A is equal to H, I'm going to keep using this picture. You guys may have to do some wonky stuff, just so you know, because I want to be able to draw it. So let's come back here. Cool. So if A is exactly equal to H, which I believe this is probably about equal, does it form a triangle yet? No, but eventually it will. And it's only this triangle. It's the only one that exists. So we're going to make that comment, and we'll just say, hey, one possibility is A is less than H. Doesn't exist. Or it's A is equal to H. How many possible triangles could we construct out of that? I wish that we'd kept the wood, but that's okay. All right, check it out. I'm not going to change this length. Is it a triangle anymore? How about now? Here it's a triangle. Is it a triangle anymore? How about now, no, any of those places? How many possible triangles will we find if this is the same as this? One. There's only one, and it's a very specific type of triangle. It's one triangle that's possible, and it's one right triangle. Now, we could just say one triangle. I'm fine with that, but it is a right triangle. All right. Now we get into a couple other cases here, and we're going to keep referring back to this picture. Okay, so far we have either no solution or one solution, and it all relies on the height and being able to find the height of our triangle. So let's go a step further. This time, I'm going to use the same picture, but I'm going to make this A side, I'm going to change the way A looks just a skosh. And I'm going to say, hey, for this one, let's get wild. I want length of side A to be greater than side B, or equal, either one. So I'm going to do side A in red, and you guys just tell me, do you agree that that's about equal? If this is A, this is about equal to B right now, right? Okay, so don't draw it horizontally like this. I'm just going to use it. Okay, so check it out. If they're equal, is this a triangle yet? No. Now, remember, the bottom side or base of our triangle can be drawn. If it's equal, could we connect it here and we'd make a true triangle? Okay, if we let it keep swinging. So here's one triangle. I can see it. Not a triangle now because it's crossing over that bottom part. When we get over here, it's not quite long enough to reach, or it's a little bit too long until we get right here. Is that a different triangle? Like, is that a triangle anymore? If we just say this and this? No, because we need that third side. Now, if A is way longer like this, obviously we can't connect it over here. In this situation, how many triangles are possible? Are you sure? This is a triangle, isn't it? Because the weird part, and I wish that we had a nice animation, this side can change length. I don't care how long this side is. All I care about is it goes out at this direction. So as long as I can touch this bottom piece anywhere, I can count that as a triangle. If I cross the bottom, I don't get to count it because I need this length. Now, I could possibly come over here, but notice this would change angle A. And that's not allowed because we're given angle A. Okay, in this situation, if A is the same or larger, only one possibility. It's this big triangle that we saw. One possible triangle. Okay, one possible. And I'm going to say one triangle. All right. This last one is that weird case. Now, all of these triangles have something in common. In your notes, do you have space to add one more to the right? Okay, so I'm going to move my whole picture one to the right. Just move that there so I can draw one to the right, sorry. Okay, so here we go. Last situation. In this, we have that weird situation that you guys saw yesterday. If I want to be able to draw two triangles like I saw you guys make, I know that it can be here or it could be here. Those are the two that you guys saw yesterday, right? Okay, my question for you. This is A and this is A. They're the same length, just different angles. I want you guys talk together for about the next minute. Bless you. I want to see if you can come up with what are the requirements that we need based on A, H, and maybe even B to give us two possible triangles. So your question is, how does the length of A, H, and B interplay here? Just like we've done A and H and A and H and A and B, I want you guys to come up with this piece here. I'm going to give you about 60 seconds. Weird. You guys sound like clicking there, right? Good. All right. So one possibility, or one requirement at least, is that we need to have H. It has to be greater than or equal to A. Whoa, that's backward. A has to be greater than or equal to H. I'm sorry. Okay. At the same time, though, there's another requirement. If I try to say side A, and you don't have to add another one, but if this is side A, is it ever going to be more than one triangle? If A is longer than B, how many triangles do we get? One. So I can't be longer because I need two of them, which means not only does A have to be bigger than the height, but it also has to be less than, what? Less than B. And I'm even going to require actually less than, because if it were the exact same length, remember, we don't make a triangle. Cool. All right. Looking at that, these guys, we are going to see the letters show up in different orders, but all of my angle A's on this picture have something in common. They're all less than 90, right? These are the four cases where I give you angle side side, and the angle that I give you is acute, right, or obtuse. All of these angle A's. These are all of the acute triangles that we could form. So if you want to make sure you can keep, or if you want to be able to keep these straight, I'm just going to say given an acute angle. Cool. Now, in contrast, we're just going to blast over these next two really fast because they're way less common. If we looked at acute angles given, reasonably, I think we are probably just going to look at obtuse angles as well. Now, the obtuse case is so much simpler. So, looking at this, if we draw it, and I guess before moving on, questions about any of these? If we need to cut pieces of paper to do this again or break balls of wood, I'm cool to do so, like we can. I should have had you keep them. Everybody feel okay with this? Okay. In the acute situation, we have all four of them. For the obtuse situation, remember, we are given an angle A, so I'm going to start here, just on this bottom side that can change length. Doesn't have to be stuck. I'm going to make that a straight line, though. So here's the bottom side. This would be side C in our picture. And I'm just going to erase it so it's a dashed line saying I don't know how long it really is. Okay. In contrast, though, we would have this angle A given. Here's my angle A. All right. If I have to make sure that this side, all that can change is its length, the angle has to stay the same. We call this side B. And then side A would be up here somewhere. Okay, so I'm just going to start here for now. And I'm going to notice something. With how I've drawn it, did I draw a triangle? If that is the length of side A, are you ever going to be able to make it a triangle without changing that angle? So we're going to fix that here in a second because it drives me crazy. What we see in this situation is that if side length A is less than B, how many triangles can we make? 0 triangles. And did I word it as 0 triangles or no? No triangle, no solution. Cool. All right. We are never going to run into 2 solutions here. I want you guys, similar idea, I'll just take this, but I want you to find me the relationship that we need for an obtuse to have 1 triangle. So we'll start all the same. Here's A and B, angle A, side B, and I assume that I could draw it here or here. Doesn't matter. I can make a triangle. In that situation, what are the requirements to ensure that we only get 1 triangle? Sean claims that A has to be greater than B. Could it be equal? How come? If you tried to have another length of B, the only way you could get it to reach that bottom of our triangle, that base, is by having a B line B, right? So we would have to have it A greater than B. Okay, no or equal to for this situation. All right. If A, again, what am I bumping? Huh. Yeah, well, or right, I don't know. I'm not sure what the noise indicates. 1 triangle. Okay, these 2 situations are for which sort of angle given? Obtuse. Cool. So, with all of this, I don't have a big enough screen to keep this up here. So we'll say given obtuse angle. Here we are. Real quickly, what is the ambiguous case? What information should be given for you to know that you have to check all this crazy extra stuff? Angle, side, excuse me. So here we go. We're going to, hopefully you can keep yours up, and I might be able to zoom out and just, it's going to be huge when we zoom back in. But there are our ambiguous cases. Okay, in my notes I have it as underneath. You guys obviously are going to write your notes however you want. I'm going to do it on the side so I can keep these up. All I want us to do is solve triangle. Piece of cake. Okay, so we're going to switch it up here. On this one, I am going to give us the same letters, I suppose. So I hate that this is going to happen, but here's example A. For this triangle, and I'm going to switch to red to present it so we don't goof it up. I tell you that I give you a triangle with side A equal to 12 units, whatever they are. Side B is equal to 5 units. And angle A, and I'm going to write it like your book does, even though it bugs me, is 31 degrees. Okay. Now, when we say solve this triangle, did I tell you what the name of the third point is? No, what are you probably going to assume it is? We're going to assume it's C, right? Okay, should we sketch this? Now, I wouldn't do it perfectly to scale, but I would suggest at least trying to pay attention a little bit to the scale. So, to orient ourselves, I'm going to draw my base. This would be side C, but I don't know how long it is. Not yet. To indicate that I don't know how long it is, I'm just going to dash it. If you don't want to dash yours, I'm completely fine with it.
5, 12, 13. Is that a triple?
So if it's a what sort of triangle, do we get to use Pythagoras rule?
You can only have triples on an acute triangle?
Nope.
Or right angle?
Right triangles. Pythagorean theorem only works with right triangles. Okay, so here's my bottom side. Am I going to really grab a protractor and get 31 degrees? No, but I can probably estimate it. It's about that. Okay, so here's 31 degrees. Love it. Okay, moving forward. I will label A here. What side is this based on everything that we've done? B, and what's its length? 5. And then side A is all that we have to worry about. So side A, I know, is roughly twice as long as this, because 12. Now, it's not going to be perfect to scale, but if I make it twice as long, is it ever going to come down here? Not a chance, which means it must come over here. Okay, here's side A, and it's 12. Now, we have angle side side. This is the ambiguous case. Now I can tell you just based on the logic that we used just now, without ever looking at the pictures, I can see how many triangles we must have because I just used the same logic that we did when we looked at that group of 6. However, if you don't want to have to draw the triangle, which category do we fit into? It's acute, so it's on the top. Do we know the height? Could we find it? Okay, so I'm going to challenge you real quick. We don't know it yet. I want you to find height. I will draw it here. And we won't always have to do this, but it's good practice. I'm going to call this H. Your guys' first step that I want you to talk through is to find H. Do not forget the mode. Just because I see you touching the calculator. Degrees. Riley, are you struggling to get? Okay. All right, so setting this up, I'll grab my fancy calculator as well. Which trig function should we use? I've highlighted that pink triangle, purple, fuchsia, I don't know what color it is. Highlighted it, it's a right triangle. Which trig function? Sine. Now notice right here on the screen, we already did this. H is B sine A. I would be very wary of following just the letters here because as soon as I change the letters, this doesn't mean anything anymore. You have to be able to make sense of the picture, whether it's X, Y, Z, A, B, C, doesn't matter. Okay, so for this, I know that the sine of 31 is H over 5. So in this situation, without ever writing letters, I know that H is exactly equal to what? 5 times the sine of 31. And you guys are going to give me an approximation of that. And we now determine that H is approximately 2 point, I'll just use 1 here. 5, 7. That was 2, but I'll take them. Okay, so checking it out. Now that we have this, just in case we wound up needing it, let's check. Is A equal to H? No. Okay. Is A less than H? What's A? Okay, so it's not. I think I might have just had that question. Is A greater than B? Okay, so I'm looking at this, I'm thinking, gosh, already I know that there's one triangle. There's no ambiguity here. There's a single triangle. One triangle. Okay, this is all thought process that I'm just using to make sense of this. I would strongly recommend using this, but let's take a look. Okay, now that we have one single triangle, does the law of sines kick in? I think so. If you want to draw the whole one, all I'm going to do is down here where I decided that it was dashed initially, I'll just make it long. Okay, we have a few things that we need to find. I know A and B. I'm trying to find side C. Cool, so I'll just put these here. These are my 6 pieces of my triangle. I happen to know 12 and 5 here already. And then I need angle A, angle B, and angle C. And we will go approximate on these two. Here's what we know. I want you guys to use the law of sines to get me the other 3 pieces. If you need help, I can help. Your classmates can help. I'm going to give you a moment. Once you have an answer, feel free to check it with me, and I will get example B set up here. I'm out of space there. All right. Pause. Okay, once you have A, if you want to check your answer, if you're good, I would suggest let's try to do B. Here we are. Now, this right triangle that I've drawn, that pink line, the only reason I drew the pink was to help us do what? Too many answers. Find how many solutions. Specifically, it was to find the height and be able to compare, just in case we needed to. Now, I'm going to move this one over a bit more, and let's dig in. Okay, just to be ultra clear, the actual triangle that we're dealing with, that height doesn't play a role yet. The real triangle we're solving is this one. And I'm going to make this even bolder, obnoxiously so. This is the real triangle. Now, it's not a right triangle. Forget about this right angle from the height. We don't need it. Okay, looking at this. We have some options. If I want to try to solve this, I know that this over here is B, and that this is C, and I hate it. Okay, from here, if I want to try to solve it, what's the angle that I already know for sure? Angle A, and I know side A. So I'm going to use that. Okay, if I write this, do you want to try to find an angle first or a side first? Angle. Is it possible that you try to find a side first? Okay, I just want to show you. It happens if you pick the wrong thing. You'll notice it right away. Don't erase. If I hypothetically wanted to find a side first, it would have to be side C, right? So using my law of sines, I would then try to do C divided by the sine of which angle? C would be equal to, which one do I know, the angle and the side? So it would be the side length A over the sine of angle A. Okay, this is how my law of sines would appear if I'm trying to solve for C. But check out what happens. If we go a step further and try to run with this idea, we get C over the sine of angle C equals 12 over the sine of 31. Do you know side length C yet? Do you know angle C yet? No. Now, if you try this first, don't erase it and go, gosh darn it, I started wrong. We can use this in a minute. We just have to hold off. We need a little bit more information. So if we try and we fail, that's okay. So let's find an angle first. Can it be angle C? Because the same thing would happen, right? Angle and side, I don't know them. So the only option is angle B. If I'm solving for the angle, should I put the angle in the numerator or denominator? Numerator is easier, but you can really put it anywhere. So here we go. The sine of B over side length of B, which is 5. Now we'll make use of that A piece. 12 over the sine of 31 degrees. Okay, this equation, just to kind of refresh, this is ugly, but it's just this rather. It's an ugly number. This is a number. This is a number. I only have one thing that I don't know in this whole expression. That's good. That's what I need. I need to solve this for B. I'm going to do 2 steps in one. First thing, I probably don't want a fraction, so we're going to bust it. What should I multiply both sides by? 5. Okay, so I will not do 2 steps in one. Everybody agree that sine of B then is apparently equal to 5 times 12 over the sine of 31. Now, I would probably just call this 60 over the sine of 31, but it's the same thing. How do we undo a sine now to solve for B? I take the arc sine or inverse sine. So, one more step here. We get B is equal to the arc sine of, and I'm going to write it this way, 60 over the sine of 31. When you ask your calculator to do this calculation for you, what do you get? 12.39? 12.39. Can you give me a couple more?
15.
Thank you. Okay. I think I can get angle C now. 31 plus 12.3915 is 43.3915. And I'm going to subtract that from 180. It must be 136 point something. Is it really 0.7? Are you sure it's not 6185? Okay, because it must have called this 0.4 or 0.3. Something's wonky here. I flipped the 12 and what? Holy cow! When did you notice it? Good. Okay, Abigail noticed some huge mistake I've made. Angle over side. Angle? I switched it, right? So this is the situation where I'm okay if you want to erase it. There's a huge typo that's going to lead to wonky answers. I flipped. One side was angle over side, and then I did side over angle. I messed them up. They have to be the same. So we're going to fix that. Thank you, Abigail. So the good news is that, what's up? You cannot. If you have a over b, 1/2 is not the same as 4/2. Like, I can't just double both of them. So, good news is I never made a mistake because now there's no evidence. This should have been the sine of what? 31 degrees. That's my bad. Over 12. All right, now we'll recalculate. And I'm going to skip a step. B is equal to the arc sine of sine of 31 over 12. Thank you, Abigail. All right, now you guys are going to hook it up. And it's probably still 12, and you guys did the right thing, and I just had it written down wrong. 12.3? Okay. And I'll use that number, which means C then, now we're on the right track. Thank you. C must be what? 136.7. Cool. Degrees. All right, well, that's almost done. Now I need side C. How on earth do we find side C? I'm going to put these in here now that I have them. I'll label my picture. That's 12.3 degrees, and this was 136.7. All right. Do I have enough to find the last side? Okay. Law of sines. I'm going to use it again. Do you want to use... I don't know what I was going to say. Where should side C be? Numerator, denominator. Numerator's easier. Does it really matter, though? You're just saving a step. So I will write it out. C over the sine of, what's that angle? Good. So 136.7 is equal to, well, should I use A and A or B and B? A and A is a better choice. Why? Good. Yeah, I didn't have to round it. Sine over sine of 31 degrees. Cool. Get me a number, and I have one more for you. It might not be this one. We'll see. Now I know it's bigger than 17. It has to be. That's called the triangle inequality. Is it bigger than 17? It might not be. I'm goofed up. 15.97. Can somebody second? We'll hold off before we commit to it. Or you might get 16.01 if you round it differently, but you're super close to this. Cool. Okay. For this, the hardest part of these problems, in my mind, is making sure we can go through and see if it's ambiguous or not. Should we do another one similar to this? All right. So, new letters, new thought process. This one, we're just going to check answers. I want you guys to do the same thing for the triangle that has Q and T and angle Q. Cool. If you want to sketch the triangle, feel free to do so. This is the triangle that I want you guys to work here. I'm going to pause it. I'm going to zoom in so I have room to work. And I will be crutching around to check on everybody. Here we are. Here's 35. And then this other side Q is 7. Now, as I look at it, it's not perfectly to scale, but that's 7. I'll call that 7 there. That's Q. Okay. From just the picture, does it look like this is going to work out? No. But if we wanted to verify that, how would we do it? I want to know there's no solution. Q is less than T. Now be really careful, because look at your no solution case. We said that A has to be less than what? The height. Where's the height on this triangle? It's not there yet, is it? So if you draw it, we can see that it will not work. Like, I can tell it's not going to work. If we wanted to add the altitude where this is on the bottom, it would be this. This is my altitude H. Could you find H from this right triangle that we've now made? So sine is H over 35, right? So H is equal to 35 times the sine of 78. Without ever having to just use the letters, we can make sense of these things. What is this approximately? 34 point something? Okay, check it out. is our given side, Q, that we're trying to put on there, is it less than H? Is 7 less than 34 something? So immediately we have, therefore, if we're never going to be able to get to the bottom, how many triangles are there? None. This is a no solution. Okay. Take the time. It's nice to have A, B, C, and use it all the same consistently. It's really nice, especially if you want to just write it down in like a formula. But be comfortable drawing your triangles weird. Make it a habit. I know it's odd to do. The base of a triangle isn't always the part that's on the bottom. You can pick any side to be the base because triangles do that. Okay, I have one more for you that I want you to get started with. You may have to find the height, but last one. And then we'll have a short assignment tonight. Cool. Okay. Do the letters matter? No. I'm still going to give you A, B, and C. Here we go. A on this last example is 12. B, side B, is 31. And the angle A that's given is 20.5 degrees. Now, drawing the triangle will help. I want us to try something though. Before you commit to drawing the triangle, let's look at this. The letters are nice right off the bat. A is less than B. All right. Right off the bat, find me your list for an acute that says A is less than B. So we better have A bigger than the height, right? This is a two possible triangle situation. This is it. A is less than B. Now, we want to be able to compare it to H as well. So what should we probably do? We should find H. At this point, might it be helpful to draw the triangle? For sure. Now, anytime I'm drawing these, anytime, all I do is I start with angle A, and I'm going to draw them weird every time. Check it out. Here's a length that I don't know what it is. This is what I'm going to count as my base, and it happens to be standing like this time. That's okay. If you want to draw them all down all the time, do you. That's fine. I want to make sure that we don't just get stuck looking at triangles the same way. Okay, so if that's A, side A, or sorry, if that's the base of my triangle, you tell me when I'm at about 20 degrees. Okay, so because I can see the size here, it's pretty small. This is 12. This is 20.5 degrees right here. And then this other side length has to be what? Here's A, and I'm goofed up, aren't I? Where does this 12 need to go? Opposite of that, I'm sorry. Which means this one needs to be way longer. This is B equals 31, and over here is my 12. Now, it is not perfect to scale. It's not, but it's pretty close. Can you see that it looks like we might just get two triangles out of this deal? Cool. Now, I want you guys, find me one of them first. When we're looking at this, because we know that A is less than B, I think we could probably calculate that A is greater than or equal to H. If we wanted the height, it's just this height right here, where we have angle, sine again. Same idea. Now, two triangles. I want you guys to start, but what that means is we have A1, B1, and C1 for our first triangle, which will be A, B, and C. And then we're also going to have angles A2, B2, and C2. There are two answers. I want you guys to give me one of them, and we're going to see that the other one is super obvious. I will give you a little time. Cool. So check it out. All I've done here, just so you guys can see, yesterday when we did that activity with the sticks, we had it here and it pivoted to here. So all I've done is I've shown that that pivot exists. Here's the big triangle, the first one that we drew, and here's the alternative in red where if I added this as my 12 instead. Okay, let's deal with this triangle first. I already know what A is, angle A. It's 20.5 degrees, guaranteed. Now, does it change on this triangle either? The angle stays the same and the two side lengths stay the same. So I know that A1 and A2 are the exact same. They have to be. All right. Similarly, A, we're told no matter what, on either of these triangles that has a length of 12, and that B, no matter what, has a length of 31. That is all of our information that we started with. Now, you may not even know what triangle you're looking at to begin with. It doesn't matter which one you call B1 and B2, irrelevant, but they are going to be different. So let's dig in. This is the natural triangle to start with, the big one. Okay, so I'm going to start by finding what on this triangle? Angle B. It has to. So let's check it out. I will do this one in blue. I know that for sure the sine of angle B divided by 31 is exactly equal to the sine of, what angle should I put in here? 20.5 over 12. Okay, B is the arc sine of 31 sine of 20.5 over 12. I hate that parentheses, we're just going to fix it. Boom. Okay. Shout it out loud when you give me a value. 64? 64.78. Okay. From just this, could we reason out what angle C is? Cool. I'm not good at decimal math, so I'm going to wait for somebody to shout that out as well. 94.72? Okay. We now know that this angle B was 64.72. Okay, everybody's on board with that first part. Now, if I want to find side C on this, am I able to? For sure. Now, let's check it out. On side C, and maybe, not maybe, we're going to see something wonky happen. I am going to call this C1 and C2. Because remember, this dash line, the length can change. This one's allowed to change. So, here we go. For the big triangle, which we've just committed to C1, how do we find side C? C over the sine of what angle? $94.72 is equal to 12 over the sine of 20.5. Okay, shout it out once you get it. $34.171218. Sorry, 175. I think. Okay, 15. Okay. Now check it out. Your homework tonight. Tomorrow we're gonna do several more of these. You're gonna do them like as an assignment in class. But I want us to think about something. I'm gonna hold you for like 30 seconds. We found that this was 64 degrees, 64.78, right? What's this length here? And what's this length here? And this is a what sort of triangle? Just this little piece. Which means if this is 64, can you tell me what this is? And if that's 64, can you tell me what this new angle B must be? 116. They have to add up to 180. Cool. Finish this problem tonight for our second triangle. We just found B together, angle B. Only thing that'll vary now is that side C, which it better be shorter because it is shorter. Cool. All right, later, Raiders. Those of you traveling, I would do the same thing for this class that you did for physics. I would just go through 6.2. I would take a short video of the pages of 6.2 and the homework. Cool. If anybody wants stuff to do on the plane because you guys understand it, just so you know, in class tomorrow, here's the assignment that we'll be doing to start. It's going to be like kumbaya. All right. Anybody on the plane who's feeling ambitious, there's the assignment that we'll do tomorrow in class. It'll count as homework. I'll catch you cool cats later.